Hello everyone, this is Kitish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 1 higher tier. In this video, I will be going through the exam question by question and provide you with notes and explanations. So let's have a look at this paper. This paper was released in 2018. It's the higher tier and it has 6 questions in total. The paper is out of 70 marks. So the paper is out of 70 marks, right? There you go, 70 marks here. And what I have done here is listed the topics that each of these questions are related. So question number 1 is related to the atomic structure. Question number 2 and 3 is related to the particle model of matter. Question 4 is atomic structure again. Question 5 is related to energy, and question number 6 is related to the electricity. Remember, there's 4 major topics for paper 1 that comes up in this exam. So let's have a look at question number 1. Question 1 is on the atomic structure. Figure 1 shows 2 models of the atom. So for figure 1, you have the plum pudding model and the nuclear model. Write the labels on figure 1. Choose the answers from the box. So these particles with the negative charges are the electrons. And this entire part here is the atom. Right? And these lines are orbits or orbit. You can call them as shells as well. Here we are using the word orbit. And what's in the middle of the atom is the nucleus. Now it's worthwhile revising the other models of the atom. Right? So if I look at the very first model of the atom, which is simply a circle or a solid sphere, that was proposed by John Dalton, his sphere model in 1803. Now the plum pudding model was proposed by J.J. Thomson, who discovered the electron. Now the electron was first discovered, then it was the nucleus, then the protons were discovered, and the neutrons were discovered last. So the nuclear model was proposed in 1913 by Niels Bohr, who said that the electrons are in energy levels. They are not just simply scattered around, right? And between that, in 1911, right, Rutherford described the nucleus with a positive charge. So after John Dalton's sphere model, the plum pudding model was described once the electron was actually discovered. So that's the first model that was described. That's the second model. And the third model was Rutherford's model, where he described the nucleus with a positive charge, where almost all the mass was concentrated and the atom was mostly empty space, using the gold foil experiment. Now that gold foil experiment is worthwhile to revise as well, because it's another area where they can ask questions on. And the final model was this. And there was a further model which was actually described, which is a quantum model, which we don't really have to go here. Right. So question 1.2, explain why the total positive charge in every atom of an element is always the same. So for an element, right, we call an atom an element depending on the number of protons, right? The positive charge is actually coming from the protons. So if I take hydrogen gas, right, as a gas, every single atom of hydrogen has just one proton. If it is helium gas, every single atom of helium has two protons, and so on. So the answer, every atom of the same element contains the same number of protons, which provides the positive charge. So the positive charge is coming from the protons, and the atoms of the same element contain the same number of protons for the second marks. Question 1.3, still on atomic structure. The results from the alpha scattering experiment led to the nuclear model. Alpha particles were fired at a thin film of gold at a speed of 7% of the speed of light. Determine the speed of the alpha particles. So what they are asking you is to find 7% of this 300 million meters per second. So you could find the speed of the alpha particle. You need to divide 300 million. If you divide that by 100, you will get 1%. You want to find 7% of that, so you multiply that by 7, which will give you 21 million. Right? You can write it in standard form just to shorten it. 2.1 times 10 to the power 7 meters per second. Figure 1.4. Question 1.4, figure 2 shows two atoms represented as solid spheres. So you've got a hydrogen atom here and a magnesium atom here. A hydrogen atom has a radius of 2.5 times 10 to the power minus 11 meters. That's for the hydrogen. Determine the radius of a magnesium atom. So they want you to determine the radius of this magnesium atom. Use measurements from figure 2. So it's a bit tricky to do this digitally, but let's see. Right. So what you would want to do is actually measure the radius of the hydrogen atom here in centimeters, and measure the radius of this magnesium atom also in centimeters, and figure out what the ratio is. Let's say this is 1 is to, let's say that's about 6 or 8, then you can multiply by that factor. So if I measure the radius of this hydrogen atom, what I get, I measure the diameter, which is 1.2 centimeters, divide that by 2, so I get 0.6 centimeters. Right? So I'm measuring the radius here, and if I measure the diameter of this magnesium atom, right, so the diameter is 7 centimeters, divide that by 2 to get the radius, which is 3.5 centimeters. Now to find the ratio, I would divide this 3.5 centimeters, 3.5 divided by 0.6. So let's do this in the calculator. 3.5 divided by 0.6 gives me 5.83. Right? 5.83. That's my ratio. That's 5.83 is to 1. So multiply that by this radius of the radius of the hydrogen atom, which is 2.5 times 10 to the power minus 11. See, multiply that by 2.5 to the power of minus 11. That gives me 1.458. I can round that off to 1.46. 1.46 times 10 to the power minus 10 meters. So that's close to 1.5. And so I'll leave it at 1.46 times 10 to the power minus 10 meters. Now, the marking scheme gives a range of acceptable answers between 1.4 to 1.6 times 10 to the power minus 10. So we've got that within the range that we actually need. That brings us to the end of question number 1. I will see you in question number